Hi everyone, my name is Angus and I'm team manager here at Team Tachyon. And today I'm going to walk you through our new car, the design principles behind it, and how we manufactured everything that goes on our car to produce the thing that races down the track. So what's interesting about our car this year is it's almost, if you have a look at it, it's almost exactly the same as the car we took to Nationals at the start of the year. But if you look more closely, we've changed and altered almost every part of it to make it go faster and to be more reliable and regulation compliant.
This year, we integrated a new innovation into our wheel support system via parting some carbon fiber wheels of this tube of the material. Now, the reason we integrated carbon fiber wheels was to minimize the weight of rotating components, because when you have heavy components rotating, they take more force to accelerate, as per Newton's second law. Therefore, by using this nice, light and strong material, we really get the most out of the pressure from the CO2 cylinder. Now, we started off with this tube of carbon fiber, generously shipped to us by Carbon Fiber Australia. Then, after loading it into the lathe, we're able to use the high-speed rotation of the lathe to part off these 16.5mm wheels. Then, using some precise jigs, we're able to place a small 3D printed spoke directly in the center. Now, with this innovation in mind, we were able to integrate this into the rest of the wheel support system very effectively, making a wheel which rotated at a great rate, one which was able to accelerate properly, and one that got us the maximum amount of performance that we could get out of the pressure cylinder. Yeah, well, what made carbon fiber so effective to use, in addition to its light weight, was its incredibly strong nature. Right, as opposed to PLA, which could easily break under excessive forces, carbon fiber is stronger.
One innovation that we used in our Nationals car earlier this year was what we call the FAT, or the Flow Accelerating Tail. So, with most cars, you have wingtips, which means wingtip vortices, like our Regionals car from this time last year. But what our FAT does is, this FAT here, it actually connects to the body of the car, so then it completely eliminates wingtip vortices. The other thing it acts to do is the area at the back of the car is generally highly turbulent in terms of airflow, so it acts to clean up that air and ensure streamlined flow of air behind the car. And go.
What is really spectacular about our front aerofoil is that we have combined the best aspects out of our previous competition's cars. Now, when we started out the competition last year, we had an open aerofoil system. Now, that meant that we didn't have the luxury of having an aligned axle, but it meant that we had a much deeper trench. Now, with this national final, and it's the same design for the state final car, having the shallower trench like this meant that we could have a closed axle support system, but that had the adverse effect of making the trench shallower. Now, this aerofoil reduced drag, whereas this aerofoil had more security and alignment. Now, with Nick's innovations in the wheel support system, we were able to go fully axleless, using separated axles for each wheel. That meant that we could open up the trench and open up the front aerofoil, reducing the frontal area and reducing drag. The wheel support system is truly an expansive assembly. Behind the wheel support system that you see is this. These are both custom designed 3D printed U-shaped support cylinders. So what they do is, this cylindrical shape is the projected surface of the wheel support system, and this U-shape keeps the axle held within it. Now, the individual axles are able to take these two wheels with their own spokes and bearings assembled within them, and they're able to slide onto the axle. Now, with the wheel assembled on, we're able to put the hubcap, which stays static as the car rotates. What this does is it allows us to prevent turbulent air from coming into the wheel. However, Since it's not rotating, it doesn't contribute to the rotational inertia of the wheel itself. We've also done some other measures to ensure that rotational inertia is minimized in the wheel support system, like the inclusion of carbon fiber. Yep.
Thanks for watching, everyone, and I hope you got something out of this video. Stay tuned to our YouTube channel on Tuesdays for Tachyon TV Tuesdays, and also feel free to check us out on Facebook and Instagram using the name Team Tachyon 2019, and also our very own website, teamtachyon2019.weebly.com. Thanks.
Your hair's messed up, bro. On the other side, it's like sticking up. This
Thanks.
side. Yeah.
You too.
Still sticking up though.
Oh, that's right.
Axles in our wheel support system.
Hang on, I can't get it to focus.